Hello everyone, and welcome to our first tutorial video that I will be recording for our class this semester in Math 242. I decided that a good topic to cover in this first video would be the first-order linear differential equations problems. Now, I'm hoping to make this into a little bit of a series. Please let me know if there are other problems either already that have been posted or in the future when I post other homework sets that you would like me to cover in videos such as these. Regardless, since this is sort of the first more difficult topic in the course, I wanted to not only go over an example problem and sort of guide you through the steps and also show you, of course, what you need to, what kind of work you need to be showing when you solve these problems, say, on an exam. I also wanted you to be able to refer to this video as just a quick refresher on what first-order linear differential equations are. And I've written out for you guys already the standard format that all first-order linear differential equations will follow. Alright, so first off, we've got, as always, our dy dx, the derivative of the function that we are trying to find. And this will be accompanied on the left-hand side by p of x, a function only of x, times y. And then on the right-hand side of the equation, we will have q of x, a function only of x. Please keep in mind that there is no more complex function of y going on here. Y must stand on its own, and it must be multiplied. You must be able to locate it or identify it in this format exactly, where it is just multiplied by a function of x. Okay, so how do we tackle these? Well, as I've gone over in lecture, but to quickly reiterate here, there are a couple steps that we need to follow. The first step, step 1, you can sort of think of this as a preliminary step, is identify and explicitly write out the formulas for p of x and q of x. On an exam, mention that we have a first order linear problem. I'm going in detail here because, again, I want you to be able to use these videos when you are working on exams or even on the final in this course to remind yourselves and to be able to check in on what kind of work I expect you to show when you submit your answers to me. So that is the first step. Write out what the values of p of x and q of x are. Now in this case, I'm not going to do that quite yet because for now I'm still going to work with this general form of the equation, but I will be doing that when I get to the example problem. Alright, once we've done that, what do? Step 2 is to get your integrating factor, which we call rho of x. This sort of p-looking thing is actually the Greek letter rho. And our integrating factor rho is always going to be equal to e to the power integral, yes, this integral is in the power, of p of x dx. Okay, so far so good. Again, the integrating factor will always be given by this very simple formula, but at this step, in step 2, you should plug this in, you should calculate this integral. So it's worth pointing that out real quick, use a different color. Calculate this integral here. Okay. Now what we're going to do next is still going to be pretty simple. We are simply going to proceed in step 3 by multiplying on both sides by our integrating factor rho of x. Okay, we are now pretty much done with the, let's say, the easier stuff. And I'm going to move things on this screen a little bit to give myself a little bit more space, because we are about to tackle the tricky section, which I am well aware that the first time we went over this in class, I didn't necessarily do the best job of explaining exactly what is going on, and more importantly, of explaining why this trick works. So let's jump right in. Step 4. Step 4 is the trick. And the trick is that at this point, you can identify the left-hand side of the equation as a derivative product rule. Okay, at this point I think I'm going to pull out a new whiteboard and show what I mean by that. Don't worry, we'll be back to this one and I'll continue on from here once I'm done with that. Alright, here we are. I'm going to go over the trick now. I've written out so far what our equation looks like at this point in the process. It should look like a rho of x times dy dx plus rho of x times p of x times y. And then on the right hand side, we have rho of x times q of x. Now I'm going to go over the details of how I can guarantee you, or how you can know, that this trick should always work. So if you're not interested in this, or if you already know this, feel free to skip ahead in this video. I'll try to put timestamps in the description. Alright, in any case, what's important at this point in time for the trick is just this left-hand side. So let's forget about the right-hand side for the moment. Okay, so we've got this, and what I'm going to claim to you guys is that this is just the result of a product rule. Okay, so what do I mean by this? Well, first remember that our rho of x is actually equal to e to the integral of p of x dx. So in other words, rho prime of x is going to be equal to the following. It's going to be equal to, by a very quick chain rule, the derivative of this top part which you can see pretty much by definition is just going to be exactly equal to p of x. I'll try to keep this color-coded. And that's our chain rule factor. And that's just going to be multiplied by e to the rho integral of p of x dx. In other words, the derivative of rho is just p of x times rho of x. Where did this guy come from? Well, again, this is just the other part of the chain rule. If you do not see how I did this, please try doing this on your own. Start with this first line with just the definition of rho of x that I've given you. Use the chain rule, find what the derivative of rho of x is going to be, and you should get exactly to this here. Now, why is this important? Well, I've just shown that this guy that we just got here, this p of x times rho of x, is equal to rho prime of x, rather. And that is exactly what shows up here. In other words, this is rho prime of x. Okay, now hopefully at this point, at least some of you should be seeing where this is going. dy dx is, of course, by definition, y prime. So what have we done here? I have now shown you guys, hopefully that you can see this, that this equation that we started with is actually equal to rho of x times y prime plus rho prime of x times y. And this is, by the product rule, you might think of this as a product rule in reverse, equal to the derivative with respect to x of rho of x times y. All right, what does this give us? What's the whole idea here? Well, it's actually pretty straightforward. The entire trick is that we can replace the entire left-hand side with this guy. That's really all that's going on in this step 4. And this is why the trick always works. As you can see in what I've done here on this very shortly on this whiteboard, there's nothing special. There's nothing that depended on a specific value of any of these functions or of any particular setup of the differential equation. This will always hold. We can always replace the left-hand side that we've gotten at this point in the process with the derivative of rho of x times y. After we do that, all we have to do is integrate on both sides with respect to x. This derivative here is going to clear on the left-hand side, and everything should be very straightforward from here on out. All right, hopefully this was much clearer than the first time I went over this. And so at this point, I'm going to go back to the original whiteboard. All right, we are back at our starting whiteboard. And let's pick up where we left off. So what I just shown on the second whiteboard is that what we're actually just doing in step 4 is the following. We're just going to replace the left-hand side with the derivative with respect to x of rho of x times y, all of that in brackets. And as you hopefully see now, we should always be able to do this without any sort of difficulty. All right, at this point, step 5 is very straightforward. Integrate with respect to x on both sides. So hopefully that's pretty straightforward. It should just speak for itself, nothing too complicated going on here, although you will need to rely on your integration skills that you've learned in calculus courses in the past. All right, step 6. After you're done integrating, you should note in step 5 that the integral of the left-hand side will just clear that derivative there. It won't do anything else. So at this point in step 6, you'll divide by rho, on both sides to isolate the formula for y. And that really does it. There's not much more to the whole process. Hopefully the sort of perhaps not obvious step in step 4, that trick that's maybe not super easy to wrap your head around initially, makes more sense now. And in practice, it's actually very simple to use. You're always going to be replacing just the left-hand side at a very specific point in time with basically always the same thing. After which point you just have to integrate and then just pass that row of x over to the other side, and you are good to go. Keep in mind that I'll put step 5 sometimes. At this point, plug in your initial condition, if any, to find the value of c. You won't always have to do that, depending on the problem that you're actually working on. It may or may not actually ask you to find the specific or particular solution of the differential equation. If they do, then at that point you just proceed as usual, just solve for c by plugging in your initial conditions. All right, what I'm going to do now is, as promised, I'm going to present one of the example problems. This is just a variation of the first problem I assigned you on your second homework set. And I'm going to work through it following this exact process with these steps. I'll be sort of mentioning them as I go along. And hopefully that should give you guys something of a template as to how I expect you guys to present your work when you're solving these problems on an exam. All right, the board is clear. Let's get to an example problem. And the one I want to work on here is going to be solve the differential equation which is going to be dy dx plus 9xy is equal to 4x. And in this case, I'm not going to give you guys any initial condition here. Hopefully that last part you guys can figure out on your own. The most important is the first 6 steps that we went over. So let's start with step 1. We're going to identify this as a first order linear equation. All right, to do that, we need to show that this is in the correct form. And we need to identify our p of x, which, as we can see on this left-hand side, the function of x that y is being multiplied by is clearly 9x. Then we also want to identify our q of x, which clearly is just what we have on the right-hand side here, and that's 4x. All right, let's write these out. We have p of x, in this case, is equal to 9x, and q of x is equal to 4x. All right, now let's move on to step 2. Step 2 is pretty straightforward. Compute the integrating factor, which is going to be rho of x is equal to e to the integral of p of x dx, which is e to the integral of 9x dx, which is going to be e to the 9/2 x squared. Usually you'd have the plus c here, but recall that when we're calculating the integrating factor, including that plus c or not is actually going to be irrelevant to the rest of the problem. All right, I'm going to make some space on the board and put this up in the corner over here. All right, let's move on to step 3. Which is very simply multiply on both sides by rho of x. And if we do this, we get rho of x times dy dx plus rho of x times 9xy is equal to rho of x times 4x. I'm going to simplify this, plug in the values of rho of x, but not quite yet. I think that it sort of will make everything messy if I do that right now. So first I'm going to proceed to step 4 and clear out this big mess that we have on the left-hand side. All right, this guy goes over here. And step 4, replace the left-hand side with the derivative with respect to x of rho of x times y. And when we do this, we're going to see that we'll have on the left-hand side exactly what I just wrote, the derivative with respect to x of rho of x times y. And the right-hand side stays exactly the same. Our right-hand side was rho of x times 4x. Okay. If we now plug in the actual values of rho of x, we'll get the following, which is we have on the left-hand side the derivative with respect to x of e to the 9/2 x squared times y is equal to, on the right-hand side, e to the 9/2 x squared times 4x. Okay. So now that we've done all this, we can proceed to step 5. Integrate on both sides with respect to x. We're going to get the following. On the left-hand side, you'll see that the integral and the derivative are going to clear each other, leaving us with e to the 9/2 x squared times y. I should point this out, that this is because the integral and the derivative canceled. All right, with that comment made, we now have the integral of the right-hand side, which is the integral of e to the 9/2 x squared times 4x dx. So at this point, I'm not going to show all the steps. I'll just simply say if you take u to be equal to 9/2 x squared and perform the u substitution, you should get, I believe, on this right-hand side, that integral is equal to 4/9 times e to the 9/2 x squared plus c. Okay, we're almost done. All that's left is to do the final step, which is, of course, step 6. Divide on both sides by rho of x, which in this case is equal to e to the 9/2 x squared. Doing this gives that y is going to be equal to 4/9 times e to the 9/2 x squared over e to the 9/2 x squared plus c divided by e to the 9/2 x squared. Now, if this were on an exam, honestly, I wouldn't require you to simplify this any further. If you left the answer as follows, as I just did, that would be perfectly fine. But in this case, the simplification is pretty straightforward. This gives us 4/9 plus c times e to the negative 9/2 x squared. And we're done. All right, that's it for this video. Hopefully this helps you guys out and gives you guys a bit of a template of how I expect you to, or at least of the steps that I expect you guys to write out. You don't necessarily need to write these problems on an exam in exactly this format, but the key parts that I've written here, so writing out in that step 1 what p of x and q of x are and pointing out that this is a first order linear equation, writing out what the integrating factor is, doing the multiplication on both sides, mentioning the trick that you're using in step 4, then integrating and dividing on both sides. All of this should show in your work if you're submitting this as part of an exam or final. All right, that's pretty much all I have for you guys on this particular problem. Please let me know if there's something you'd like to change about this, and especially please let me know if there are any other particular problems, either now or in the future, that you would like me to cover in a similar type of video. All right, stay safe, stay healthy, and I'll see you guys in class.